I've been planning on building a lathe for turning wood, and I was thinking I'd build it kind of robust, and maybe I could turn some little metal pieces on it because I occasionally need a bushing or something. But then I realized that's kind of silly. Let's build a metalworking lathe, and then I can use it to build a better woodworking lathe. My projects in the past have often been compromised because I don't have the ability to turn, or haven't had the ability to turn. So I'm going to put that to rest. I'm going to build a lathe. So I'm out here kind of looking around at what kind of steel I have. And I think I'm going to use this H-pile. It's a 1489. It's really beefy. And I want beefy. This is not going to be a pretty lathe. I'm not going to spend hours and hours grinding edges to make them look like they came out of a shop with a big saw, which I don't have. And I do have a DC treadmill motor. Actually, I have two. This one's good to go. The other one, I have some parts ordered for it. So I can have a motor for the metalworking lathe and the woodworking lathe. And I like these motors because they have a variable speed control. I don't have to rely on a bunch of pulleys or gears, which is going to make the build a lot simpler. So at 89 pounds a foot and a little over 4 feet long, obviously I can't lift this thing. So we get the forklift, pick it up, bring it into the shop and do some swapping from one crane to the next and get it up on my work table so I can begin to remove some excess steel to kind of trim this thing down a little bit. So either I have too much stuff or my shop's not big enough, but I can't get the forklift in there and get it to my work table without moving a whole lot of stuff. So I got it to the overhead crane, which rolled it down to another overhead crane, a manual one, over my workbench. And I shifted the weight to that one, and I got it on my workbench. All the while kind of being careful because this thing's heavy enough to really hurt me if it were to slide or smash my finger or something. And unfortunately, I'm not one of those guys that can do SketchUp. I don't have the mental discipline to draw this out. I really don't know what I'm going to do step by step, but I definitely will do steps, and one after the other, and we will get it to working like a engine lathe should. I put a beam and a trolley and this chain fall over my workbench when I did the when my wife and I did the memorial bronze sculpture for the hospital, and because it was really too heavy and awkward to handle safely without it. And if I wouldn't have done it then, I'd be doing it now because I can't even flip this thing over right now until I get some weight off of it. It's massively heavy. So tired of getting holes burned through my tennis shoes and into my foot, I'm actually wearing leather boots and my Nomex to make this a little more comfortable because I knew I was just going to be doing nothing but cutting and grinding for a couple of days. This is my plasma torch, and I'm cutting the flanges. They're 3/4 of an inch thick, and it is all my torch wanted. It really couldn't cut clean through it, but it cut most of the way. And I did a bunch of cuts with it and messed up the tip. It kind of melted. But for now, this is as good as it gets, and I have to go back afterwards with the big grinder and finish the cut. But it's still like way faster than doing the whole thing with just the grinder. So this is first step. I'm just trying to square up the ends, which are torch cut by a blind man. Trying to get them looking more or less as square as I can do it. There's a lot of these lathe builds on the internet, and some of these guys do absolutely beautiful work, and some guys just buy a whole lot of pieces, parts, and probably spend more than if they just wanted to go buy a lathe. My attitude is make do with what I have. So like the title says, this one's not going to be a pretty lathe, but it should be stout and should be usable. That's my goal. Now the web of this H-pile is 5/8, and the plasma torch didn't really have a problem with 5/8. Most of the problem was me and my unsteady hands. But I did get better as the next couple of days went on, and I could actually cut semi-straight line. I do have an edge clamped on there to follow. It makes it a whole lot easier. So this plasma torch, well, all plasma torches, they do not have, there's no flammable gas involved. There's no propylene, there's no acetylene. There's no gas. It doesn't burn. It's strictly electric. The electricity makes the heat and blows some compressed air through there, and it's just amazing what these things will do. This is a medium powered one. The next size up would have burned through that 3/4 like butter. Just I love this thing. The more I use it, the more I like it. Wasn't cheap. So like I said earlier, this is an H-pile, not a beam. It's meant to be used vertically. And the case of where I got it from, we did some flood walls in New Orleans after Katrina, and we had literally thousands of these things driven in the ground. They hold up the flood walls. Very seldom did they come to the site less than 120 feet long, some 140, some of them, according to what the plans call for, some of them had to be driven and then another piece welded on top, just because you can only truck a pile in so long. And there were lots and lots of drops that I could have brought home, but they're so heavy that I didn't. The only ones I brought home, 4 beams. They're up above the fluorescent lights. They hold the roof up. They're like 100 times stronger than they need to be. And this little piece was a drop from one of those. Otherwise, I don't mess with this heavy stuff. It's just too awkward for me. So the intersection between the flange and the web kind of gave me a hard time. It's a whole lot of metal, and the plasma torch just kind of mucked it up, and the grinder wouldn't reach totally. So spent a little time on that, but I only have to do that 2 more times, that intersection cut. Well, I said I was getting better at the plasma torch, but looking at this clip, it doesn't look like I got any better. It looks like I got worse. But I'm cutting a curve, and I'm using a round piece of aluminum to kind of guide the tip of the torch, try to give a pleasing curve. The base is cut to shape. I still can't pick it up, it's heavy as it all get out. But what I'm going to do now is go ahead and clean it up, grind all the edges, get all the rust off. Because 1, if I don't do it now, I probably never will. And 2, I'm not really sure what to do next. I'm going to go get some grinding wheels for the scary grinder, the 7-inch grinder, and hopefully make quick work of all these raggedy ends and get it prettied up. And I'll be thinking about what to do next. Preliminary cleanup done. It's looking a lot better. Probably could grind on it for a long time, but we're getting close. Next step is the ways. That's what the carriage slides on. Okay, I have this stainless steel shaft. It's like 14 feet long. And I have this stainless steel shaft. They're not the same size, but one of the other is going to be the Headstock axis shaft. I need to mic them, see what size they are, and see what size bearings I can get my hands on, and that will determine which one of these I'm going to use. And then I can rough shape or rough draw the headstock, and then I will know where the ways can start. Okay, I'm going to use the 1 3/4 shaft, old boat shaft, for the headstock, and I'm ordered some 1 3/4 pillow block bearings. And I'll have to get this shaft turned down because they'll both be the same size, so I'll need to take 1,000 off of it. And I'm going to use this stainless steel prop shaft, which came out of a 1970 wooden Grand Banks I cut up. And I'm going to cut it for the guide rails for the carriage. So I'm going to get 2 of these. Somehow or another I'm going to mount it down, and somehow or another I'll make some slides to fit over it. But this is stainless and it's slick. And if I use this, I only have to machine the other part, not both parts, not the top and the bottom. This will be the bottom. I kind of messed up here. These prop shafts are over 50 years old, and I don't know that the flange has ever been removed from them. It has 2 set bolts one on each side. I was able to get them loose and started beating, and I didn't realize that the set bolts were screwed into a hole that was drilled on each side of the shaft, so I was kind of like fighting against myself here. Once I figured it out and took the set screws all the way out, the flanges actually came off, and I have plans on using both of them. One's pretty battered right now, but I should be able to turn it and make it round again. I can always count on this grinder to trip the breaker the first time I hit the trigger. After that, we're good. So this is the 1.5-inch prop shaft. I'm using it as the ways, the base for the ways. This will be the part that the carriage rides back and forth on. So I cut the mangled end off that I mangled, and I'm cutting 2 pieces to length to put on the lathe body.
So I got the round bar flush with the outside with these 2 braces, and I got it snug down. Now the beam, believe it or not, is not straight. Came from a construction site, so no telling what its history is. It might have got run over by a bulldozer or something, but I believe the prop shaft is straight. So I put clamps on this end. I didn't pull it down tight on this end because there was a little gap, not much, maybe a 64th or something. I got a few tacks on it, take the clamps off of it, and this aluminum extrusion is pretty straight, so I'm using it as a straight edge. And if everything's lovely, I'm going to put the one on the opposite side and tack it into place. So according to my little spacer gauge, they're parallel, and I got them clamped down lightly. Well, no, that's not parallel. That's got a bump in it. This one's moved a little bit, so I think I'm gonna have to make a tack, and then go along and tap it back and forth with the hammer to get these as parallel as I can. So I'm using the drop that I cut off of the bottom of the main beam to make the bottom of the slider, and I'm going to try to cut this with the plasma torch, and then I'm going to rip it with the plasma torch. So we're going to give that old torch a workout today for sure, like yesterday.
So about now I was working up a pretty good case of frustration. I finally melted the tip on the plasma torch. It's a consumable, so I needed to get another one. But my wife was working on a patina. I didn't want to leave her here. She needs occasional help with technology stuff. And I ran out of cutoff wheels for the big grinder, so I pulled out the torch, which I hate. And I was trying to cut with the torch, but I got torch issues and I got gauge issues. I realized that the acetylene gauge was not working. It let the pressure get up real high, which is dangerous because acetylene is not a safe gas. Anyway, it was just frustrating.
So that took close to 3 hours. I don't have any manly angle iron, nothing even halfway heavy, so I cut this channel, and I got 2 of them. They're not equal legs. One leg's tapered and one's not, but it doesn't matter. So got my angle irons. I'm getting ready to build a slide. All right, so after the frustration of cutting this plate, I set it on those 2 angles that I had cut from the channel and tacked each end, and it slides wonderfully. And I haven't even polished the inside of the angles. I just kind of grinded them, and there's no wobble, and there's no wobble that way. So I will have to anchor them so it can't come up. Maybe just put some set screws here, or maybe come underneath here. I'm not sure, but for now I'm going to put a few more wells to make sure it's good. Take it off, turn it upside down, and brace it for keeps forever. But this one's welded. This one's got 1 tack at the end, and then I made my special marking tool to get this dimension here to make sure it's the same down here, and it is. So I'm just gonna put 1 tack here until I get the glide fixed up, because you never know. I hate to weld it all up and have to grind it off. But I'm good now. Put enough tack on it where it won't move without a hammer, and move forward. Okay, so the other half of my big drop is going to be the top of my cross slide. I just need to cut it here and use this part. And the way I got them flip-flopped, I don't have to cut that waist, what's that? It's not the flange, that's the web, because that would be just a absolute bear to get rid of that. But it's not hurting anything where it is, so I'll cut this, and I have good blades for my big grinder, and I have a working plasma torch, so this should go fairly smooth. Okay, we're starting out day number 3. I cut this little piece out of what was left of the web of the beam, and this will be the turntable, and it's going to go on top of there. So I'm going to clean this up and drill a hole right in the middle of it, and then decide where to drill this one and drill a hole. It'll be a big hole, like at least 5/8, because it'll be the pivot for the upper slide. I don't know really what the thing's called. Okay, I got the cross slide tacked into place. I got the angles tacked, and they slide on the round bars really well without wobble. I haven't polished these yet. I haven't polished these. I haven't polished the bottom of the angles, so it doesn't slide quite as well as the big one. The big one slides good, and I'm calling it a day. I'm a whoop puppy. I don't have a lot of giant sized bits, but I do have this one, which is just a tad over 3/4. So I was able to find a 3/4 bolt, and that's going to be the pivot for the upper slide. Okay, day 3, morning. First thing I need to do is get this height equal to this height, because if not, the plate's going to sit crooked. And they're close, but they're not right yet. So I'm going to have to, maybe I'll just clamp them together and use a file to get the tops flat and straight. Set up the guide, it's upside down. Got it clamped across the top so these angles are level. And I got it marked with the blue tape, and I put a little tack here, a little tack here. So I should be able to take off this, and put the calipers here, and make sure they're the same down here. Knock them around, and I'll put a little tack, and I'm really not too sure if this whole thing's going to work, so I'm not going to over weld it, but I'm going to put enough weld where it won't move around. So the further I go on this part of it, my confidence is waning. I'm just not sure it's going to work, but anyway, I'm going to keep on going for now. So this is welded to this, which will be welded to that. This will be welded, but this connection here will have oversized holes. So to take up any slack, I'll just need to tap this over, and it'll tighten up in this wedge, and then tap this down, and then tighten up the bolts. So that's the plan. It's really stiff. Even this side that I got welded already, it just doesn't slide easily, but it doesn't have to slide far, and I'll have a screw pulling on it. So I'm gonna keep going, see what happens. It's either gonna work or it's not, but I'm ready to tack the rectangular tubes down. On this side, I drilled and tapped 4 1/4 by 20s into the rectangular tube, and the holes in the angle are oversized so I can move it around. If it's not strong enough, I can add 3 more, or I can drill these out and put some bigger ones. Yeah, I don't know. I'm gonna tack it and see how it slides, if it slides easy or if it slides at all. I don't think there'll be too much slop. I can take the slop out. It's just a matter of whether it'll slide without binding. Okay, it doesn't work, and I kind of knew it wasn't gonna work. By the time you tap this down enough to get the side-to-side play out of it, it binds up. And I'm just have one hand here, but if you don't, I think these angles are just too acute. It's just not going to work. So, all right, we'll punt on this top part, and I'm gonna start working on the lead screw for this part, and just scratch my head a little bit on the top part. 2, 3, 4 hours lost. Happens sometimes.
Okay, so this is a good spot to end this video. Next time we're going to look at getting some screws to pull the carriages back and forth, and that'll be a little more finesse work and a little less of the grunt work with messing with this heavy steel. So thanks for watching, and we'll get a new video out fairly soon.